Assalamualaikum and very good day to everyone. Today I would like to present my proposal with title 4G LTE and 5G electromagnetic radiation detection and monitoring system for public awareness. My name is Siti Nurhamiza binti Ibrahim and my supervisor is Professor Madya Dr. Shafa Zahira binti Sapuan. This is my presentation outline. Firstly, I would like to introduce my background of study, followed by problem statement, objective, scope of project, and next literature review, research methodology, and the expected result. Next, background of study. First, electromagnetic EM radiation consists of natural radiation and the man-made radiation that are produced either internationally or as byproduct. This radiation comes across through wire and wireless transmitter or receiver, electrical or electronic device and system. Any electrical device is surrounded by invisible line of force called the electric and magnetic field (EMF). Voltage create electric field which are stronger as the voltage increase. So, in the recent year, everyone, include kids, has been exposed to complex admission of electric and magnetic field, both at the home or at the work, from power generation and transmission, household appliances and industrial equipment through telecommunication and broadcasting. The new part, background of study. The increased use of wireless communication device raised serious concern about the considerable radiation that this device emit and the potential health problem that could result from it. Exposure limit has been specified by WHO and the INIPS. EMF are visible line associated with the use of electric power, the time varying electromagnetic field produced by electrical appliances of for example, extremely low frequency ELF field. Electromagnetic radiation should not excess the radiation limit proposed by INIPS. Therefore, the maximum allowed field limit has been followed by human safety. So for this project, the general public limit to taken into the operational frequency of at 0.9 GHz, 1.8 GHz, 2.1 GHz, 2.6 GHz and 3.5 GHz where the radiation intensity must be below 500 voltage per meter. The next part is problem statement. First, lately with the increasing rate of mobile phone usage and the increasing number of users, billions of people around the world are exposed to radiation from mobile phone. Second, there is about 500 meter gaps between mobile phone based transmitter station BTS in some city, while more than 30 cell tower can be seen within a kilometer in other places where there are no restriction on tower placement. Next, the data measured by a traditional method is offline and is not real-time result. This is a very difficult and to give a real picture of the RF radiation level to the public. And lastly is the area monitoring facilities used by is very expensive and require expert in RF radiation field to read data in specific website. The data is very limited due to the limited number of RF detector places in Malaysia. Objective for this project are to design single band electromagnetic EM radiation detector at 0.9 GHz, 1.8 GHz, 2.1 GHz, 2.6 GHz and 3.5 GHz. Next, to develop the EM mobile measuring system that has capability to convert directly from RF to DC voltage for Internet of Things IoT. And the last is to calculate the antenna factor AF using analytical method for the purpose antenna and compare with simulation and measuring method using standard antenna method. Next, scope of the project. First, the system is capable of measuring the electric field at the frequency of 0.9 GHz, 1.8 GHz, 2.1 GHz, 2.6 GHz and 3.5 GHz, which are chosen due to the application in antenna for the telecommunication equipment for base station based on the MCMC regulation. And the last is the receiver is a single band antenna that is connected to the RF detector circuit. is to be enable measurement to be done for specific frequency accurately. For the part literature review, I will summarize with a topic: A. Theory of electromagnetic field. B. Health concern. C. EM radiation measurement. D. EM detector. And the last is 5G communication. Next, for the part methodology, this is a project sequence overview. Flowchart used to explain how this project will be developed and to ensure a better understanding of the project evaluation. So, the work start with the receiver stage, followed by the detector and amplifier stage, calibration stage, and the last is IoT platform development stage. Initially, the receiver stage, bidirectional multiband electromagnetic EM radiation detector capable of performing automatic measurement of the E field at the frequency used and will be designed, fabricated, and tested. The next step would be to develop algorithm to extract the value of E field from the individual frequency component of the mobile phone frequency, which are included in detector and amplifier stage as well as in calibration stage. This E field value will compare with the limit proposed by INITS. The final stage could be the IoT platform development. The new device, once accepted in terms of accuracy and reliability, could be store the e-field information to the IoT platform. The data can be accessed within the IoT platform itself. Continue part for the methodology. This is a block diagram for the overall system. The antenna measure the radiation level and the output voltage will be converted to DC signal by using RF detector. RF converter will be used to convert the AC signal to DC signal. Based on this figure, 5 different single band antenna are needed for this project for AF determination in order to ensure the E-field value from the operating frequency of the antenna itself. The single band antenna also can decrease interference during antenna data collection, since that the antenna used in on RF detector which focus only single frequency. For the part microcontroller, as used as a main processor in designing the calibration stage of the electromagnetic radiation detector. The microcontroller receives the input voltage from the detector and measure the E-field value, and then the limit suggested by INIT will be compared to the E-field reading from these 5 antenna, and then the extract E-field information will be stored to the IoT platform, and the data will be accessed within the IoT platform itself. As a result, as an end user will be access the data displayed in the IoT platform via any internet enabled device. For the last part is expected result. By the end of this project, the fundamental aim of this project was expected to be successful to design an electromagnetic radiation detector, and this is able to sense radiation emitted by antenna. Next, and this antenna will be used at the telecommunication base station or any place exposed to electromagnetic radiation which operate at GSM frequency 0.9 GHz, 1.8 GHz, 2.1 GHz, 2.6 GHz, and last 3.5 GHz. Next, bidirectional multiband electromagnetic EM radiation detector was expected successful of performing automatic measurement of E-field from the individual frequency component of the GSM bands used in the RF detector system. And the last is the extract the value will be used to determine whether is success or not the specific range of predetermined safety exposure standard set by INITS for the public. Okay, this is a visual the expected result for the overall system. First, start from the receiver and converter stage. Next, this is a microcontroller, and this is a collaboration stage, and this is a IoT platform, and the data can be accessed within the IoT platform itself, which is a interface data login. Okay, that's all from me. Thank you for listening.